Okay, this is the last in a series of videos on points of concurrency, and points of concurrency are simply a fancy name for points where certain drawings interlap or certain folds overlap, intersect. So we first talked about circumcenters and where you took perpendicular bisectors of each side and they intersect at a point. And then we talked about in-center where you took the angle bisectors and they all intersect at a point called the in-center. Then we did medians and we found the centroid, which is the intersection of the three medians. And now we're going to talk about the orthocenter. And the orthocenter is the point at which the three altitudes of a triangle intersect each other. Okay, so we're going to be drawing altitude. So you might think, what is an altitude? Well, the first thing I think of when I think of an altitude is flying on a plane and the pilot saying we're now flying at 30,000 feet, and that's the altitude of the plane. And the altitude is simply the measure from the plane to the ground. So how far off of the ground is this plane flying? So I'm going to kind of use that to help with these constructions, these series of constructions. So the first thing I'm going to do is look at a scalene triangle, okay? Scalene acute triangle, and I'll put a little plane up here because when I draw planes, my students laugh at me, so we're just going to use this one. All right, so basically if I wanted to measure the distance from this plane, and we're going to pretend that the plane is right at the vertex here, okay? So we want to measure the distance from the plane to the ground, and the ground is going to be the opposite side. So if we wanted to measure the distance, again, we talked about the distance is always in a perpendicular manner. So the distance from a point to a line or a point to a line segment has to be measured in a perpendicular way. Well, in order to make a perpendicular angle, you're going to need to fold a side over top of itself, and that makes a perpendicular angle because you have opposite rays or overlapping, and so you'll automatically make a perpendicular angle. But the challenge here is that we want to make a perpendicular angle, but we want to include the vertex that has the little plane. So we want to measure from the plane to the ground. So we're going to fold it at the vertex here, but we want to keep track of the fact that the vertex is involved in this fold. But look at the bottom here. We have to kind of slide it around so that it makes a perpendicular angle or a 90-degree angle. So we're going to fold it all the way from the plane to the ground, okay? So that is going to be our altitude, and we're going to mark it. And then we're going to use our little perpendicular symbol to indicate that it is a perpendicular, it's perpendicular from the vertex to the opposite side. All right, now we're going to do another vertex. Now the plane is from this side of the triangle, and we're going to measure from the plane to the opposite side. Now the opposite side is the side that's not involved in the vertex, okay? And that'll come in a little bit more helpful later when you don't have a scalene triangle. So we want to go from the plane to the opposite side, so we're going to involve the vertex where the plane is and make the ground form a 90-degree angle because we're measuring the altitude from the plane to the ground, and so we kind of have to scooch the ground to overlap itself, if you will. All right, so the fold includes the vertex and forces the ground to be at a perpendicular angle. So we're going to do that, and we're going to do it again on the third side. Again, these are altitudes, and the third side is up here. So the plane is now flying over this ground. We're going to fold it so that we include the vertex, and the opposite side is a perpendicular angle. So this is the advantage of using patty paper. You can see through and make that fold. So nice. Okay, so we're going to use another color, and hopefully if your folds are accurate, then your three folds will intersect at a point, and that point is called the orthocenter. So this is the orthocenter. All right, let's do another one. What if you have a right triangle? Well, right triangles are kind of cool because they're already perpendicular. There's already a perpendicular angle here. So if I were to measure the distance from the plane to the ground in a perpendicular way, well, it's already there. That's the side of the right triangle. So this fold, if you will, has already happened. There's nothing to fold. All right, so now let's make the plane be at another vertex. Remember that this vertex includes these two sides, so I want to be perpendicular to the other side that's not part of that vertex. So the other side that's not part of the vertex where the plane is happens to be this side. Well, look, if I were to measure from the plane to this side down here in a perpendicular way, it's already this side. So we've already done two sides by simply looking at the sides. Now the third side that I didn't measure was at that perpendicular angle. So we already measured the perpendicular, or we already indicated that if the plane were here, it would be along this side, the measurement. If the plane were here, then the altitude would be along that side. So we just need that third altitude. Now here, the plane is flying above the ground, and this bottom part is the ground. So when you fold the vertex, because this time we actually have to do some folding, when you fold the vertex, and you want the opposite side to be perpendicular, so you have to include, try to make that vertex as best in the fold as you can. It's a little hard sometimes, especially if you have kind of a wide pencil or something, because then you don't see it very well, okay? So then remember that the altitudes for this vertex and this vertex were here. So the third altitude is here. It's actually from, remember we had the plane here at the vertex, and we went to the opposite side. So if you want to look at the intersection of the three altitudes actually intersect at this corner right here. So the orthocenter of a right triangle ends up being at the corner. It ends up being at the intersection, because we had this altitude, and then this altitude. So that one's a little easier. Well, don't get comfortable, because the next one is a little more challenging, but it's the same kind of concept that we've been talking through. So try not to stress out. All right, so what if you had an obtuse triangle? So I'll start with kind of the easiest angle. Again, we're measuring from the plane to the opposite side. Think of the opposite side as the ground. And so we want it to be perpendicular. So we're going to fold from the vertex, just like we've been doing, to the opposite side in such a way that we make a perpendicular angle. So the opposite side overlaps itself, and we include the vertex as best as possible. Okay? So now we want our plane to be over here. So here's our plane, and he's flying over here, and he's flying in this angle right here, which means which side is the opposite side? The ground or the opposite side is here. Now the problem is, if you look at this plane and he's flying over the ground, you know that the distance between the plane and the ground is going to look something like this, like you can sort of visualize that the perpendicular angle is here. But the problem is we ran out of ground. So just think of the plane as flying over the ocean. So what we're going to do is we're going to actually extend our ground, because it's really hard to find the perpendicular of a side that is invisible. All right, so we're going to extend the ground. We're just going to extend the side. So if you look at it now, the plane flying over this ground, you can see a perpendicular angle would be something like this. So we're still going to include the vertex that we were talking about like we were before, but now when we make that perpendicular angle, we're going to make it over the new ground, over the water, if you think of it like kind of like that way. All right, so we're including the vertex, and we're including the new ground that we drew, the extended, and we're just folding it over itself. So that is the altitude, because that would be the distance if a plane were flying over water. That would be the perpendicular distance from the plane to the ground. Okay, so there's that one, and this is the perpendicular symbol. All right, so we have one. Let me go ahead and label that one that we had earlier. I folded it, but I didn't label it. Sorry about that. It's kind of hard to see white on white. Okay, so when the plane was at this vertex, we found the altitude, that's green. The plane was at this vertex. So the third vertex for the plane is this one over here, all right? So you're looking at this and you're like, what is going on? So remember, this is the angle, and we want to find a perpendicular way to the opposite side, this ground. So I sort of have to adjust the triangle so that you can see that you can visualize from the plane to the ground would look more like this. We're just missing some ground. So we're going to extend the side of that ground area. Think of it like the plane, flying over water, right? So we want the vertical distance from the plane to the ground has to include that angle. All right, so that's why we had to extend it. Now we're going to use the same vertex that the plane was at, and we're going to fold it over in a perpendicular way to include the opposite side. Okay, and then we're going to mark it. Okay, and we're going to use this color, blue. And what was it perpendicular to? It was perpendicular to this, right? So we did, we did do something perpendicular here, okay? Now, if you'll notice, the three altitudes, the orange, the green, and the blue altitudes actually meet at the orthocenter. And in this case, the orthocenter actually fell outside the triangle. So we had an orthocenter that was inside the triangle. That was our original one, the orthocenter. Those are my three altitudes. We have an orthocenter outside the triangle, and then we had an orthocenter that was actually on the triangle. So sometimes the orthocenter is not always inside the triangle, so it's one of these three. So let's just look at this real quick and remind ourselves of what we did. We drew an altitude, which means it's the perpendicular distance from a vertex to the opposite side. Sometimes you had to extend the side because of the way the triangle was shaped. That's okay. You did all three of those, and wherever those three altitudes intersect are called the orthocenter. Good luck.